The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to wrap up section 10.4 part 2, and tonight's homework will be 10.4 part 2 as well as the chapter review. Tomorrow, Wednesday, we will review for the chapter 10 test. Thursday, Veterans Day, no class, no Zoom, no office hour, nada, zip. Celebrate Veterans Day. Friday, there will be no class in that no Zoom class meeting. Friday, you need to take your test, finishing it by 11:59 p.m. Friday night. And again, you can take it before then, but once you open the test, the time starts. Okay, so I want to do a review of what we did yesterday. We looked at quadratic equations in the form of this. Y. Okay, why is it not? Here we go. Y equals a times the quantity x minus h squared plus k. We found that if a was greater than 0, we got a parabola that opened upwards. If a was less than 0, we got a parabola that opened downwards. The lowest point on a parabola opening upwards, or the highest point on a parabola opening downwards, was called the vertex. And right through the vertex, there is always a line, the axis of symmetry, about which the parabola is symmetric. We also found that the axis of symmetry is an equation in the form x equals h. And the vertex is an ordered pair in the form h, k. We need to be careful because the x value is h, so it's the opposite of this, or I should say the inverse of that, same thing, and k is the constant outside of the equation. So for example, let's say we had y equals -2 times the quantity x plus 4 squared minus 7. Well, this parabola, since a is -2, it would open downwards. The axis of symmetry would be x equals -4, and the vertex would be at -4, -7. To graph this parabola, if we were using just normal techniques in class using paper, we'd put the vertex in the middle of the table and then use integer values, find the corresponding y values, and plot the graph. However, using WebAssign, we just need to plot the vertex first, and then just find one other ordered pair that is a solution to the equation, and then plot that second point. Okay, now today, our accomplishments are going to be roughly the same thing, that is to graph parabolas, but the form of the equations are going to be different. Instead of the form y equals a times x minus h squared plus k, we're going to use the form y equals ax squared plus bx plus c. Now, the a in this form is always going to be the same as the a in that form. So in this form, again, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. However, the axis of symmetry is at x equals -b over 2a. So on the first one we looked at yesterday, it's at x equals h. Now in this form, it's x equals -b over 2a. And the vertex is at -b over 2a. Recall that the x value of the vertex is always the same as the x value of the axis of symmetry. And then once we've determined that x value, we plug that back in to the function, so it'd be f of -b over 2a. All right. Now, and then from there, graphing, same thing, you'd graph the vertex and find another point that's a solution to the equation. Let's put this into practice. So let's take a look at problem number 3 over here in WebAssign. It says f of x equals x squared plus 4x plus 3. Okay. It says find the vertex and the axis of symmetry. Well, for this equation, A is 1, B is 4, and C is 3. Even though it asks us to find the vertex first, I'm going to find the axis of symmetry first. So using x equals negative b over 2a, that would be negative 4 over 2 times 1, or negative 4 over 2, or negative 2. So the axis of symmetry is at x equals negative 2. And let me remind you, if you just put in negative 2, it's going to be wrong. You've got to put in that it's an equation, x equals negative 2. All right. Now, that also means that the x value of the vertex is negative 2. So the vertex is at negative 2, comma, and then this is going to be f of negative 2. All right. So let's see. If I put in f of negative 2, that's negative 2, the quantity squared, plus 4 times negative 2 plus 3. Negative 2 times negative 2 is 4, plus what? Negative 8, plus 3, which is 7 minus 8 is negative 1. So the vertex is at negative 2, negative 1. So let's see here, negative 2, comma, oops, I need to use a comma, space, negative 1. Okay, now, will the graph open upward or downward? A is a positive number, so it'll open upwards. And there you have it. Any questions about this example? All right, let's take a look at problem number 4. So we've got f of x equals negative x squared plus 6x minus 14. So A is negative 1, B is 6, and C is negative 14. To find the axis of symmetry, x equals negative b over 2a, which is negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is 3. So the axis of symmetry is x equals 3. Okay. The vertex, oops, the vertex is at 3, comma, f of 3. And f of 3 is negative 3 squared plus 6 times 3 minus 14. Up here, the x is being squared, not the negative. The negative is outside of the square. So we're going to do the square first, 9, then attach the negative. Plus 18 minus 14 is what? Negative 5, I believe. So this is negative 5. So, oh, I've messed up already, haven't I? This should be x equals 3. And then this should be 3, negative 5. A is negative, so this parabola opens downwards. And there we have it. Again, any questions about that particular problem?
No, thank you.
What's that?
No, thank you.
Oh, okay, all righty. Thanks for letting me know. Okay, let's see here. That's the same stuff. That's the same. Okay, now we're going to look at some new stuff, but it's actually old stuff in that. Let's say we go back to linear equations, something like y equals 2x plus 4. And we want to find the x-intercept. How do you find an x-intercept? You set y equal to 0. To find an x-intercept, you set y equal to 0. Okay, so if y is 0, 0 equals 2x plus 4. Plus 4. Subtract 4 from both sides. Negative 4 equals 2x. Divide by 2. X equals negative 2. So for this equation, the x-intercept is at negative 2, 0. It's an ordered pair. Now, to find the y-intercept, we would set x equal to 0. Y equals 2 times 0 plus 4. Y equals 4. We get that, okay? So to find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. Any questions about that? Now that's with a linear equation. Now we're looking at a quadratic equation, problem number 7, but the rules haven't changed. To find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. So let's take our function f of x equals x squared minus 4x minus 45. Okay. To find the x-intercepts, we would set y equal to 0. Recall that f of x is the function notation for y. So setting it equal to 0, we would get that. Well, how do we solve that? Well, it's a quadratic equation. It's in standard form. We'll use the quadratic formula. A equals 1, B equals negative 4, C equals negative 45. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying, x equals 4 plus or minus the square root of 16. And then we've got minus 4 times 1, which would be, what, negative 4. And that's times negative 45, which is positive 180. That's all over 2. So x equals 4 plus or minus the square root of 196 over 2. X equals 4 plus or minus, I believe that 196 is 14 squared. Let's see. Yeah, so the square root of 196 is 14. That's all over 2. So x equals 4 plus 14 over 2, which is 18 over 2, which is 9. X equals 4 minus 14 over 2, which is negative 10 over 2, which is negative 5. So x equals 9, x equals negative 5. So the x-intercepts, I'm trying to avoid having to erase things here. X-intercepts are at 9, 0, and negative 5, 0. Oh, so when you're taking a second degree or quadratic equation and you're setting it equal to 0, and you're solving it for x, you're finding the x-intercepts of the graph, okay? Now, here's where we need to be careful. There's 2 x-intercepts for this problem, but it says smaller x value, larger x value. So even if you get these right over here, but you put them backwards over here, WebAssign is going to mark them wrong. So negative 5, 0, okay? That's the smaller x value. And then 9, 0. Also, it's an ordered pair. Don't just put negative 5 or 9, okay? Now, how do you find the y-intercept? By setting x equal to 0. So we've got y equals x squared minus 4x minus 45. If we set x equal to 0, we get 0 minus 0 minus 45, we get negative 45. So if an equation is in the form y equals ax squared plus bx plus c, the y-intercept is always going to be c, or the constant, because these two terms have x in them. So if x is 0, they're going to go away. So the y-intercept is going to be at 0, negative 45. And again, make sure that you get the x values and the y values correct. Don't get them switched around. These are common mistakes I see your predecessors doing. Okay, so we'll submit the answer. And it's correct. Any questions about that? All right. Do you need another example like number 7, or are you okay to go on?
I'm okay to go on.
All right, and no one else complained, so we'll keep going. All right, so here we're going to have the full picture. We're going to take an equation. We're going to find the vertex, the x-intercepts, the y-intercepts, and then we're going to graph it. Okay. So actually, hang on a second. Let me see something here. Here, let's do this. Well, I want to do this one. And the reason I want to do this one is because it has 2 x-intercepts. All right. So we've got f of x. When would a graph only have 1 x-intercept? If it was the vertex. All right, f of x equals 2x squared minus 8x plus 6. So we've got a equals 2, b equals negative 8, c equals 6. It doesn't ask for the axis of symmetry, but to find the vertex, I have to find the x value, which is the same x value as for the axis of symmetry. So I'm going to use x equals negative b over 2a, which is negative times negative 8 over 2 times 2, which is 8 over 4 or 2. So the axis of symmetry is at x equals 2. All right. So the vertex is going to be at 2 comma f of 2. And f of 2 is 2 times 2 squared minus 8 times 2 plus 6. 2 times 4 minus 16 plus 6. 8 minus 16 plus 6, which is negative 2. So the vertex is at 2, negative 2. 2 comma negative 2. Okay. Now let's find the x-intercepts. So to find the x-intercepts, set y equal to 0. So we've got 0 equals 2x squared minus 8x plus 6. Oh, you know what? I could reduce that down before I plug it into the quadratic formula by dividing everybody by 2. I don't have to, but it just makes my numbers smaller. All right. So now a is 1, b is negative 4, and c is 3. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 4 plus or minus the square root of 16 minus 12 all over 2. X equals 4 plus or minus the square root of 4 over 2. X equals 4 plus or minus 2 over 2. X equals 4 plus 2 over 2, which is 6 over 2 or 3. X equals 4 minus 2 over 2, which is 2 over 2, which is 1. So we've got x-intercepts at negative 1 comma 0, 3 comma 0. And I deliberately wrote them so that the smaller one was first. So negative 1 comma 0. And then positive 3 comma 0. All right. So there's our x-intercepts. Any questions about anything I've done so far? Okay. Tell you what, down here, let's find the y-intercept. So we set x equal to 0. and we get 6. So the y-intercept is at 0, 6. Okay. 0, 6. Now, we've got our vertex, we've got 2 x-intercepts and a y-intercept. Recall from yesterday's lesson, to graph a parabola, I click on this button, the parabola opening upwards until it turns blue. Then I must graph the vertex first. So 2, -2. And then I plot one additional point. Well, I've got 3 additional points that I've already found. I can use any one of those. Tell you what, let's use the y-intercept, 3, 0. Wait a second, x-intercept, 3, 0. That would be right there. Okay, I'm going to go over here and make sure that my points are what I wanted. 2, -2 is the vertex. 3, 0 is another point on the graph. So that should be correct. And there we have it. All right. X-intercept, -1, 0. Oh, you know what? I made a mistake right here. I can't read my own writing. Look at that. That should have been a positive one. In my sloppiness, I picked that up as a negative. So we'll come back here and fix that. Fortunately for me, that wasn't one of the points I picked to graph. Let's see what happens now. Now, when you're doing your homework, like I'm doing here, that's fine. But on the test, you only get one shot. So you really want to check your work. It just, you know, and again, that's what I get for my sloppy handwriting. Okay. Are you okay with this? Do you have any questions about this process?
I'm good.
All right. So now we're going to take a look at some application problems. And to do that, I'm going to switch screens. I'm going to go back here to this screen. Give me just a second here. And okay. So now can you see my whiteboard screen again?
Yep.
Excellent. All right. When a parabola, that is the graph of a quadratic equation, opens upwards, the vertex is at the bottom. When a parabola opens downwards, the vertex is at the top. Now, thinking in terms of x and y, the parabola, the vertex has an x value and a y value, right? Okay. For a parabola that opens upwards, the y value of the vertex is said to be the minimum, or the minimum value. For a parabola that opens downwards, the y value is said to be the maximum value. Okay? Why is that important? We're going to look at some application problems where we're going to be using quadratic equations, and quite often the answer or answers to the problem are going to lie within the vertex of the parabola. Sometimes the x value, sometimes the y value, sometimes both, depending on what it asks for. Okay, so here's a problem that says the cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes n the machine is run by the function C of n equals 2.2 n squared minus 66 n plus 655. Now let me go through this again. The cost C in dollars, so C is the cost in dollars of operating a certain concrete cutting machine is related to the number of minutes in the machine is run. So N is the input, and that's the number of minutes the machine is run. C of N is the output, and that's the cost, okay? For what number of minutes is the cost of running the machine a minimum? And what is the minimum cost? All right, now, we're not going to go to the trouble of doing an accurate graph of this parabola, but can you see that A is 2.2? So A is greater than 0. So our parabola is going to open upwards, okay? And I'm not labeling the graph because, again, I'm just, in fact, here, let's not even put that there. It's going to open upwards. Everybody okay with that so far? All right. So the vertex would be an ordered pair in C of N, right? N would be the input and C of N would be the output. But in fact, N stands for the number of minutes. So number of minutes, and C of N stands for the cost. Okay. So every point on that graph, the input is the number of minutes and the output is the cost. It says, for what number of minutes is the cost of running the machine a minimum? Well, the minimum cost would be the output of the vertex. So it wants to know for what number of minutes is the output the minimum. So basically, we need to find the input value of the vertex. Okay. Now, even though our equation is in and C, I'm going to go back to this. Okay, let's see. A is 2.2, B is negative 66. So this would be negative times negative 66 over 2 times 2.2, which would be 66 over 4.4. Okay. And 66 divided by 4.4 is 15. So our ordered pair is 15 and then C of 15. You still with me? Okay, so far? So what I know now, 15 minutes is the time that produces the minimum cost. I've already answered the first question that said, for what number of minutes is the cost of running the machine a minimum? And then it says, what is the minimum cost? So that's going to be the output value, C of 15, 2.2 times 15 squared minus 66 times 15 plus 655. And on my calculator, let's see, 2.2 times 15 squared minus 66 times 15 plus 655, and I come up with 160. Okay, so the number of minutes, 15 minutes would be, and the cost, $160. Okay. Any questions about that problem? So again, basically the answers were within the vertex. Be careful. A common mistake is students get the vertex and then they answer the questions backwards. They use 160 for the number of minutes and 15 for the cost or something. So pay close attention to what those variables stand for. All right, let's take a look at another problem. Fireworks. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height, S, in feet after t seconds, is approximated by the equation S equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, first of all, I'm going to take this equation and I'm going to put it in standard form, which would be negative 16t squared plus 120t. Okay, now notice that A, the coefficient of the leading term, is -16. When A is less than 0, what's going to happen? This thing's going to open downwards. Okay, which makes sense. If we're shooting a rocket or fireworks into the air, isn't it going to go up and then come down? It's not going to go down and then come back up, right? Okay, so here's a rough sketch of what this should look like. Now, let's see here. If the shell is designed to explode when it reaches its maximum height, after how long after being fired and at what height will the fireworks appear in the sky? All right, our ordered pairs are in the form T and S, where T is time in seconds, and S is height in feet. Okay, so we've got time in seconds, height in feet. So basically I need to find the vertex. So A is -16, B is 120. For this case, C is 0, isn't it? We don't need C, but C is 0. I'm going to go with X equals -B over 2A, -120 over 2 times -16, which is 120 over 32. Negative divided by negative is positive. 120 divided by 32 is 3.75. So that's the time, right? 3.75 seconds. And then to find the height, you'd take S equals 120 times, oh wait, I should use this form, shouldn't I? Hang on here, let's see. So that would be -B, oh, S -16 times 3.75 squared plus 120 times 3.75. Sorry, I got confused there. I forgot I was in the form where I can easily go in and get stuff to change things around. Okay, so let's see what that gives us. -16 times 3.75 squared plus 120 times 3.75, and I get 225, and that's feet. So the vertex is at 3.75, 225. 3.75 is the number of seconds it takes to reach the vertex, and 225 is the number of feet that it is above the ground. All right, so going back to our questions, how long after being fired and at what height will the fireworks appear in the sky? So after 3.75 seconds, it is 225 feet in the sky. Any questions about that one? So again, we had to find the vertex to answer the questions. Here is another example. Okay. It says, see the illustration. A farmer wants to fence in 3 sides of a rectangular. Let me draw a picture here. Okay. So we've got, let's see. Let's get a. All right. So we're going to build this fence. And we've got some lovely cows here. You can see, oh, that cow only has 2 legs. Okay. Obviously, I'm not an art teacher, maybe a con artist, but all right. So it says, see the illustration. A farmer wants to fence in 3 sides of a rectangular field with 1,000 feet of fencing. The other side of the rectangle will be a river. If the enclosed area is to be maximum, find the dimensions of the field. First of all, as someone who lived on a cattle ranch for many years, I can tell you this farmer is going to lose his herd. they're going to wander out into the river, maybe cross it, maybe drown, but a river will not keep the cows in. Just saying. Okay, but moving on. We have 1,000 feet of fence. So this piece plus this piece plus this piece equals 1,000 feet. Okay, now I'm going to take a piece of paper and fold it up, and I'll show it to you here in a second. Right. Let's say that this represents the 3 sides of the fence that are going to be built. Okay, since it's a rectangle, we can assume that this side and this side are equal. Any questions about that? All right, the total length of the 3 pieces of fence is 1,000 feet. They told us he had 1,000 feet. So if this piece is X and this piece is X, what is left would be 1,000 minus 2x. All right, any questions about that? Okay, now let's go back to the problem. It says a farmer wants to fence in 3 sides of a rectangular field with 1,000 feet of fencing. The other side of the rectangle will be the river. If the enclosed area is to be maximum, find the dimensions of the field. So we want to maximize the area for the cows to graze in the pasture. Okay, all right, now the formula for area is length times width. All right, so let's call this the width and this the length, and it doesn't matter which one we call which as long as we're consistent. So the area, and I'm going to write it as a function, the area would be the length, which is 1,000 minus 2x times the width, which is x. Okay, so a of x equals 1,000 x minus 2x squared. I'm going to write that in standard form. So there's the equation that describes the area. Are we okay with that? Any questions so far? All right, now, in this particular problem, the leading coefficient is -2. So once again, we have a parabola that opens downwards, okay? So our vertex would be x and a of x. The x value would be what? The width, and the y value, or the corresponding output value, would be the area. And it said we're supposed to find if the area is to be maximum, find the dimensions of the field. So we don't even have to find the area, we have to find the dimensions of the field though. Okay, so I need to find x to plug here and plug in here. So let's see here. How am I going to do that? Well, x equals -b over 2a. And a is -2 and b is 1,000. So this would be -1,000 over 2 times -2. Negative divided by negative is positive. 1,000 over 4 is 250. So x equals 250. That's the input value of the vertex. Now, it asks for the dimensions. So this would be 250 feet. 1,000 minus 2 times 250, 1,000 minus 500, this would be 500 feet. So the dimensions are 250 feet by 500 feet. It didn't ask for the maximum area, but if it did, I would either find A of 250, or I could just take 250 times 500 to find the maximum area, okay? This particular problem, it didn't ask for it. Any questions on that one? All righty. Let's see here. How are we doing for time? 11:10. We got time for one more. This says maximizing revenue, as in money that you bring in a business. The revenue R received for selling X stereos is given by the formula R equals -x squared over 5 plus 80x minus 1,000. How many stereos must be sold to obtain the maximum revenue? Find the maximum revenue. Okay, so X is the number of stereos sold. R is the revenue. So our ordered pairs are going to be of the form XR, and this is what number of stereos sold, and this is revenue. Okay, all right. How many stereos must be sold to obtain the maximum revenue? Here again, this equation is in standard form. A is negative, so the graph is going to open downwards. The vertex is going to be the number of stereos sold to produce the maximum revenue. So basically, I need to find the vertex, okay? A is careful, -1/5, and B is 80. You see where I got the -1/5 for A? Because there's an implied 1 in front of the x squared, so -1/5, okay? X equals -b over 2a, -80 over 2 times -1/5 is 80 over 2/5, which is 80 divided by 2/5, which is 80 times 5/2, which is 40 times 5 or 200. I kind of ripped through that quickly. Are you okay with that? So X is 200, and then R equals -200 squared over 5 plus 80 times 200 minus 1,000. Let's see what we get there. Okay, so 200 squared is 40,000. So we've got negative, oh, and then divided by 5. So we've got -8,000 plus, let's see here, -8,000 plus 80 times 200 minus 1,000. And we get, so this is what, 16,000 minus 1,000, which is 7,000. So that would be dollars, right? So stereos, $7,000. So answering the question, how many stereos must be sold? 200 stereos. What is the maximum revenue? $7,000. Okay. Read the questions carefully. Identify what your variables stand for so that when you get your vertex, you know which value to use for which answer. All righty. I will be back this afternoon at 1:15 with an office hour should you have need of me. Again, recall that, or don't forget that the assignment tonight is not only to finish section 10.4, but also the chapter review so that we can review tomorrow. No class on Thursday, test on Friday.